Good morning, my lovely kiddos and my future mathematicians. Today we are finishing up Chapter 7 in 7.5, all about trapezoids. Okay, so just like any of the shapes that we have recently been talking about, these trapezoids are going to have some rules to them. So I'm going to draw a very basic trapezoid right now, and then we are going to discuss its rules. Okay, so the first rule or the first definition about trapezoids is that it has two bases. Now we remember like the base or bottom of a triangle, but a trapezoid has two bases, and these are the two parallel sides. Okay, in this case, in this stereotypical trapezoid, it would be the top and the bottom. And remember, we notate parallel lines with these little arrows here. Okay, our second rule or something about trapezoids is that it has two legs, just like a triangle. And these are the two non-parallel sides. Okay, so we can see that these two sides, if we were to follow them up, they would eventually touch. So these are not parallel lines. So these two are our legs. Okay, just like a triangle. Okay, our third thing about trapezoids, and again, just like a triangle, is we have our base angles. Remember that our base angles are angles that are formed by both legs and the same base. Okay, so with triangles, we only had one pair of base angles per triangle. But here, since we have two bases, we're going to have two pairs of base angles. Okay, so this top base here, we can have two base angles touching both the legs and the same top base. And then down here on our second base, we can have two base angles, one touching each of the legs and the same base. Okay. Again, our fourth thing about trapezoids, and just like triangles, we can have an isosceles trapezoid. Okay, an isosceles trapezoids, it just makes the two legs congruent. Okay, so I'm going to add little tick marks on our legs here. And then what would a geometry video be without a theorem? So our fifth thing about trapezoids is that we can use the isosceles trapezoid base angle theorem. And this theorem says that if we have a trapezoid, an isosceles trapezoid where the two legs are congruent, then the top pair of base angles, let me scoot this down so you can see, the top pair of base angles would be congruent and the bottom pair of base angles would also be congruent. Okay, so let's go ahead and do an example here. So we can see that we have a trapezoid QT, SR, and we want to find the missing angles of T, Q, and R. We can find R pretty quick because this is our second base angle to S. Remember that if we have an isosceles trapezoid, which we do because we have the legs that are congruent, we have tick marks here, then we can say that both of the base angles are congruent using the same base. So since R touches the bottom base as well as S, we know that R is also 82 degrees. Okay, now we can find Q and T, but I want to point out first that they are congruent because again, we have an isosceles trapezoid and they are both touching the top base here. Okay, the way that we're going to find Q and T, which are the same measure, they are congruent, is we are going to think way, way, way back to chapter 3 last semester, where we had two parallel lines and a transversal cutting through them. Okay, this is where we had our alternate interior angles, our alternate exterior angles, our consecutive interior angles, and our complementary angles. Okay, specifically, I want to remember our consecutive interior angles. And the reason why I can draw this conclusion here is because these two lines are parallel, being cut by a transversal. So we could think of our two bases being our parallel lines, and this segment ST being our transversal. Okay, which would make angle T and angle S consecutive interior angles. So if you remember from way back then, consecutive interior angles are supplementary, or they add to 180. So to find angle T, we would simply just take 180 and subtract what we know, which is angle S at 82 degrees. And we would get, I'm going to check my math just to be sure here, 98. That's what I thought. So that means that angle T and angle Q are 98 degrees. They are congruent because of the isosceles trapezoid base angles theorem, and they were consecutive because of the consecutive interior angles theorem. We also have some more similarities to triangles with trapezoids, and that is that trapezoids have mid-segments. So just drawing a quick picture here, I'm going to draw a trapezoid, and then I'm going to draw a mid-segment. And remember, a mid-segment is just the connection between the two midpoints. Okay, now this mid-segment has a couple of special rules also. The first special rule is that it is parallel to the other two sides, or other bases. It is parallel to those. And the second cool rule is that we have a formula to solve for the length of the mid-segment. Okay, I'm going to name the top base base 1 and the bottom base base 2. Okay, and then this just being the mid-segment. And our formula says that if we take half of our base 1 plus our base 2, so we add the two bases together and then divide by 2, that will give us our mid-segment. Okay, so let's go ahead and do an example of that. All right, so we have a trapezoid that looks like this. We have our mid-segment, and the mid-segment is MN. Again, all three of these are parallel. We know that the base 1, or the top base, is 57 units, and we know that the bottom base, or base 2, is 76 units. So to solve for MN, what we're going to have to do is we're going to have to take half and then add the two bases up, so 57 plus 76, and that's going to give us our mid-segment. So let's bring in the calculator. We have 57 plus 76 divided by 2. Ooh, not 5. 2. And that's going to give us the 66.5. So MN, our mid-segment, is 66.5. Okay. Now let's do one that's kind of in a different order here. Okay, so we have points D, point C, our mid-segment at MN, and then A and B. We know that N is a midpoint of CB because both halves have tick marks on it. We know that M is the midpoint of AD because they both have tick marks on it. Again, we know that all of these are parallel. We know that DC is equal to 10 units. We know our mid-segment is equal to 7 units, but we don't know the other base. So we can still use our formula. We just have to plug in what we know and solve for something else. So again, we're going to take half our base 1, which we don't know, our smaller base, AB, plus our larger base, DC, which is 10. And that is equal to our mid-segment of 7. So to solve this, the first thing we have to do is get rid of this half. So we would divide by the half. And remember, we can't divide by fractions. We have to multiply by the reciprocal or flip it. So we are multiplying by 2 over 1 or just 2. 2 over 1 times 1/2, those are going to cancel because they go to 1, leaving us with just what's inside the fraction here, or inside the parentheses, my apologies. And then 7 times 2 gives us 14. To solve for our missing base, we're just going to subtract 10, once on each side of the equal sign, and get that B1 is equal to 4. So A to B is equal to 4 units.